it's a good pleasure to be here and to present for you today. Let me first introduce myself. I am Muhammad Alfakhori. I am from Palestine. I work at the Palestine Polytechnic University as a literature. My major is geomatics engineering and surveying, and I teach at the university photogrammetry and GIS. So today we are gonna talk briefly about photogrammetry, and we will discuss a little bit closer in close range photogrammetry. So our agenda for today, we are gonna have an introduction about photogrammetry and what type of photogrammetry we have, and the advantages of photogrammetry also we have, and the procedure from taking photos to presenting the 3D models and what output that we can present. And we'll discuss briefly the uses of photogrammetry in different fields and in different and finally, I will show you the case study that we have in Palestine about the close range photogrammetry. So in the beginning, what is photogrammetry? Photogrammetry simply it's an art and science of making measurement from photograph. So in the typical survey, we have to go to the field using like total station or using GPS to make field measurement, like an area, like a coordinate. This is what we used in the past to go to the field, to have a full crew and go. In photogrammetry, it's different. It's only you need just photos. So when we talk about measurement, what we mean about measurement? We can get the coordinates in any coordinate system that we have and that we have defined. We can get distances, and also we can calculate the area depending on the coordinates. And also because we are using photogrammetry in 3D perspective, and if we have a 3D model that we can calculate the height of buildings and height of mountains and hills, and also we can calculate the volumes for cut and fill project. This is just a picture that emphasizes that we can do like a measurement on the photograph. We have many types of photogrammetry. We have photographs from satellite. It's mainly used for remote sensing. It's low resolution. We consider it like 30-meter resolution or 60-meter resolution. It's good for macro analysis. And also we have an airborne photogrammetry. This type of photogrammetry is very famous and very used because we use it a lot. It's when the camera are on an airplane. And the third, we have its terrestrial photo that we can use like close range photogrammetry and using for on-land photogrammetry. Actually, this is the first image. It's a satellite. We get an imaging sensor on it, and he's taking photograph. Can be in visible band or in other bands also. And this is an unarmed aircraft taking a photo on this strip. And this is simple diagram of terrestrial photogrammetry. So we are having two photos of a facade, and we calculate and get a model for that facade. Yeah. So let's now speak about the advantages of that photogrammetry. Photogrammetry, you go to the field once. Just one time, you go to the field, get some points, and you have the photo, and you will process it in the office. It's time effective, so it's gonna be less because you have the photo and you're gonna process it. No need for go to the field and no need for transportation. And the cost also will be less. You have one trained person who will do this. And it can be automatized. So it's less manual effort will be, and more data. When you go into the field, usually what you get like a coordinate of this tree and this road you measure. But in photograph, you can do any measurement you want. So in the future, if you have the data and you want to make more measurements, you have it. If you want to make measurement for the road, the side of the road, or anything else in the photo, then this is that you can do. Yeah. Now we will go through the steps briefly from taking the photo and to the final stages where we put the final image. First of all, this is what we called strip series of photo in one line. We call it a strip. This is a flight line. The airplane moves, and we have a strip of photo, adjacent photo. It's simple, and the concept on the satellite photogrammetry and on terrestrial photogrammetry is the same. Yeah. This is the station 1 for taking photo, and this is station 2, station 3, and so on, and this is the flight line we have. We noticed that we have an overlap between each photo. Like from here we have 60 to 70 overlap, and we call it forward lap or simply end lap. This is between adjacent photo, and between two strips we have also a lap from 25 to 40% overlap. And this is we used to get a 3D. Same principle as a human eye. In human eye, we have two eyes, we see in two perspectives. Also, in the photogrammetry, we have two photos with the same point, so we can have two perspectives. Depending on simpler equation called collinearity equation, we can calculate the height of that point. This is the same. We have the right photo, we have the left photo with different coordinates, with exposure station, and at the same object we have here, we have coordinate on the right photo and coordinate on the left photo. So we can calculate the x, y, and also z, the height of the feature that we have. Yeah. Also, when we process the photos we have, after adding the photo, we need to set the camera calibration sheet, the camera parameter, we need to set them, and we need to add what we call tie bond. Tie bond, it means common point between two photos that are location on the photo are known, but location on the ground are unknown. And also, we can add ground control point. This is the field measurement. We can get like a unique tile corner, like a pavement, like a street marker. This is natural. So we can go to the nature, go to the field, and check for something like this and measure it using traditional surveying like GPS or translation. Otherwise, if we're working in the desert or in an area there is no unique or there is no man-made feature like this, what we can do is add artificial target. This is what we call artificial target. It gets specification, so it can be visible on the photo, and we will add it, print it on the ground, and we will take measurement using what type of devices, surveying devices that we have. After that, we have the photos. It's already calibrated, and already we have tie bond and we have ground control bond. What we do is what we call bundle adjustment. We mix it all together, and we will have a 3D model of what we have. This is the 3D model, and the coordinates is absolute coordinates. We have it, and the height also is. So, at the final stages, what we can reduce is like digital elevation model, because in what we show you, we have the heights. So we can reduce a digital elevation model, which is a map that represents the heights. So we can see the yellow color is the lowest point and the red is the highest point. Also, we can create a digital orthophoto. Orthophoto, that means it's a map, not a photograph. Now we are talking about map. Map, it means that the scale all around the photo is correct and there's no distortion. The camera distortion, the lens distortion has been corrected. So we can make measurements on that orthophoto. In the regular photo, we cannot, because the scale is different and there's some tilt and there's some distortion also. Basically, we can use photogrammetry in many types, mostly in engineering. You can use it to make some surveying, intermittent accuracy, of course, and we can use for mapping and archaeology and cultural heritage. We use it in cultural heritage for sites that we can take close range photogrammetry using your mobile or using a regular camera, and so on. We have many of uses. This is, they're using photogrammetry for archaeology. They're taking multiple photos of this site and they produce a 3D replica of it. Also in agriculture, what we can do is that we can add an infrared sensor, so we can sense the good and the bad leaves. So if it's good, it's going to be more chlorophyll, more reflex, and if it's bad or yellow leaf, it's going to be less chlorophyll. Now I'll talk about the close range photogrammetry, the case that we have in Palestine. We used a small quadcopter, a DJI quadcopter. It's very small, it's like 2 kilos weight, and it's connected via mobile. It goes only up to half a kilometer in the flight, and we created the flight plan for it to around our campus, and we started taking the photo. This is what we have. We have every photo. Of course, the camera have a GPS on it. It's not accurate GPS, accuracy up to 2 or 3 meters, but it's good for as an initial processing, not for final processing, only for initial processing. So we have every image. We have the latitude and longitude and height of it, and also we have the pitch, roll, and yaw. This is after we added all the images. We have all these images, and we have the 3D. The first step, we will create what we call auto tie point. Auto tie point will go to pixel by pixel. He will try to detect the similar point, and we will get first of it a tie point, and then we will create a dense point, which is more dense here, and we will create a pointy cloud, and after that we will create a mesh. Yeah, we will create a mesh and texture. This is one of the steps where we add the ground control point, so we'll make it absolute coordinate. And this is the final product that we have. This is an orthophoto. It's much bigger, but I take a small area so you can detect the accuracy. The accuracy of this one, it's around 5 to 10 centimeters. 5 to 10 centimeters, and the time we took like 20 minutes for taking photos. This is like 20,000 meters square, this area. Yeah, and we took 20 minutes to take a photo, and like 8 hours or 9 hours. It depends on the power of the meter that you have or the station you have of a processing. So in less than half a day, we have an orthophoto, and we have a digital elevation model of that area. And now I will present a video. It's computer generated. This is computer generated. It's not true. This is sorry. Yeah. Actually, this is pointy cloud. It's not real. And we texturize it and add the color on it. You can notice the accuracy on that. The curvature is correct, and also the right angle is correct. And what we used also, we used a 3D printer because we have a 3D printer, and we printed this mosque and put it, so we have a 3D version and we have a real version. Finally, I just want to thank CGMT and GSI Training Institute for giving me this chance, and for sure I want to thank the government of India